Welcome to G Fun Facts Online. Imagine you're an astronomer, scanning through images of the distant universe. You're used to seeing galaxies, stars, and nebulae. But then, you spot something else. A faint, perfectly circular ghost of a ring, larger than an entire galaxy, glowing in radio waves but completely invisible in every other kind of light. Your first thought? What is that? That's exactly what happened in 2019, when astronomers stumbled upon one of the biggest mysteries in modern astrophysics: colossal cosmic smoke rings they unpretentiously named odd radio circles, or ORCs. Today, we're diving into the story of these enigmatic objects, the quest to understand what they are and what they tell us about the violent and beautiful universe we live in. The discovery of ORCs wasn't a planned event. It was a complete accident, a serendipitous find in a flood of new data. In late 2019, astronomer Dr. Anna Kapinska was sifting through the first results from a revolutionary new telescope, the Australian Square Kilometre Array Pathfinder, or ASKAP. This powerful instrument, located in the radio-quiet desert of Western Australia, was designed to map the southern sky in unprecedented detail. As Kapinska examined the images, she started a list of features that simply didn't make sense. And on that list was a faint, ethereal circle of radio emission. Just a few days later, a colleague, Dr. Emil Lenk, independently found a second one. At first, there was skepticism. Circular shapes aren't totally unheard of in radio astronomy. They can be remnants of exploded stars or certain types of galaxies. But these were different. They were enormous, and located far away from the crowded plane of our own Milky Way galaxy. The real puzzle piece fell into place when they checked data from optical, infrared, and X-ray telescopes. Where the radio telescope saw a clear ring, every other telescope saw nothing, just empty space. This invisibility outside the radio spectrum was what made them so bizarre, and what earned them the name odd radio circles. The discovery sent a buzz through the astronomy community, sparking theories from plausible shockwaves to exotic ideas like the throats of wormholes. So what exactly makes these circles so odd? Let's break down the anatomy of this cosmic enigma. First, their sheer size is mind-boggling. ORCs are colossal, spanning hundreds of thousands and in some cases millions of light-years across. For perspective, our entire Milky Way galaxy is only about 100,000 light-years in diameter. Some of these rings are large enough to swallow an entire galaxy whole. Second, their shape. They are remarkably circular, with their brightness concentrated along the edges. This gives them the appearance of a giant bubble, suggesting we're looking at the edge of a vast, spherical shell of energy. Perhaps the most mystifying part is their spectral signature. They are radio ghosts. The fact that we can't see them in visible light, infrared, or X-rays means the physical process creating them is very specific. The leading explanation is something called synchrotron radiation. This happens when superfast electrons, moving near the speed of light, spiral around magnetic field lines. So, for an ORC to exist, you need a source of these high-energy electrons and a magnetic field. Finally, there's a crucial clue at the heart of the mystery. Most, though not all, ORCs have a massive elliptical galaxy sitting right at their geometric center. This strongly suggests these central galaxies are the engines that power the ORCs, the origin point of whatever created these immense structures. And the mystery only deepens. As of today, over a dozen ORCs have been found, some with even stranger features, like double rings that intersect like a Venn diagram, challenging our simplest explanations. With the evidence laid out, astronomers have become cosmic detectives, trying to reconstruct the events that could create an ORC. Several major theories are now in competition. Let's investigate the suspects. Theory number 1. The echo of a cosmic cataclysm. Imagine one of the most violent events the universe has to offer: the merger of two supermassive black holes. When two galaxies collide, their central black holes, each with the mass of billions of suns, spiral into each other and merge. This event would release an unimaginable amount of energy, sending a powerful, spherical shockwave expanding outwards into the thin gas between galaxies. As this shockwave travels, it could accelerate electrons to near light speed, which would then interact with magnetic fields and glow with the synchrotron radiation we see as an ORC. This theory is great because it explains the immense energy and the spherical shape, but it has a problem. Galaxy mergers are common. If this was the only cause, we should see thousands of ORCs, not just a dozen or so. Why are they so rare? Theory number 2. The breath of a newborn starburst. Another leading idea involves what's called a starburst galaxy. This is a galaxy experiencing a furious, rapid burst of star formation, often triggered by a merger. This frenzy of star birth is followed by a frenzy of star death, as massive stars explode as supernovae. The combined energy from thousands of these explosions can drive a powerful superwind out of the galaxy. This wind plows into the surrounding intergalactic medium, creating another massive, expanding shockwave that could, in theory, form an ORC. This model has strong supporting evidence. A detailed study of one ORC, known as ORC-4, found that its central galaxy showed signs of a past, powerful starburst event. Computer simulations suggest a galactic wind, blowing for about 200 million years before shutting off, could create the exact kind of structure we see. But again, it faces the rarity problem. Many galaxies have starbursts, so why don't they all have ORCs? Perhaps a very specific set of conditions is needed. Theory number 3. A cosmic illusion. Could an ORC be something more common, just viewed from a special angle? Many galaxies have active supermassive black holes at their centers that shoot out powerful jets of particles. We usually see these jets as two lobes of radio emission, stretching out in opposite directions. This theory suggests that if we were looking directly down the barrel of one of these conical jets, it might appear as a ring. The bright edges would just be an effect of looking through more of the emitting material at the edge of the cone. While clever, this idea struggles to explain the near-perfect circularity of some ORCs and the complex internal structures that newer, more detailed images have revealed. And finally, a more recent and complex idea, a two-act play. The discovery of X-rays coming from one ORC, nicknamed the cloverleaf, has led to a hybrid theory. The X-rays point to hot gas from a group of a dozen merging galaxies inside the ORC. The theory goes like this. Act 1. Past activity from the supermassive black holes in these galaxies created a huge cloud of energetic electrons that eventually faded. Act 2. The shock waves from the current galaxy merger smashed into this old cloud, re-energizing the relic electrons and making them glow again in radio waves, while also heating up the gas to produce X-rays. This model could solve some of the energy problems that other theories have. What's clear is that there might not be a single, one-size-fits-all explanation. ORCs may be a diverse family of objects, created by different cosmic events. None of this would be possible without the incredible technology of modern radio telescopes. The discovery was made by ASKAP in Australia, a telescope with a huge field of view, making it the perfect discovery machine for finding rare things. Once found, astronomers turned to telescopes like Meerkat in South Africa. Meerkat is the most sensitive telescope of its kind and can zoom in to capture stunningly detailed images, revealing the complex internal structures and magnetic fields of the ORCs. And then there's LOFAR, a network of antennas across Europe that observes the universe at very low radio frequencies, which is perfect for spotting the faint diffuse signals from ORCs. It's this trio of next-generation telescopes that opened the window to a previously unknown phenomenon. In our age of big data and AI, You might think scientific discovery is left entirely to professionals and algorithms. But the story of ORCs proves that the human brain's ability for pattern recognition is still irreplaceable. In fact, some of the most exciting recent ORC discoveries were made not by professional astronomers, but by citizen scientists. An Indian project called Rad at Home provides trained volunteers with access to huge radio survey datasets. By visually inspecting LOFAR data, these volunteers have identified several new ORCs, including a spectacular double-ringed one. It turns out that automated algorithms, which are trained to find known patterns, can easily miss something as truly bizarre and faint as an ORC. The human eye is still one of the best tools we have for spotting the unexpected, proving that anyone with a curious mind can contribute to the cutting edge of science. So the mystery of the odd radio circles continues. These ghostly rings, discovered by pure chance, have challenged our understanding of how galaxies evolve and have given us a new window into the most extreme physics in the cosmos. Are they the dying echoes of black hole mergers, the expanding shells of galactic superwinds, or something else entirely? The next decade promises to be a golden age for solving this puzzle. The Square Kilometre Array, or SKA, the world's largest radio telescope, is now being built in Australia and South Africa. It will be orders of magnitude more sensitive than anything we have today and is expected to uncover thousands of ORCs. This will finally give us a large enough sample to understand their origins. The story of the cosmic smoke rings is a powerful reminder that the universe is far from being fully understood. With every new window we open, we are greeted with fresh wonders and even deeper questions. The search for answers has only just begun.